Hello and welcome to homework 8.09. This is all about solving quadratic equations. Alright, so let's take a look at what we have here. Number one, which of the following is the solution set to the equation 4 parentheses x plus 3 parentheses x minus 2 equals 0? Alright, so this one is already kind of set up for us. And what we learned in class is something called the zero product rule, which is when you have a chain of things that are multiplying to 0, that guarantees that one of the things in the chain has to be 0. All right? If everything is multiplying to 0, because that's what's going on here, 4 times x plus 3 times x minus 2, this is all multiplication here, one of those things has to be 0. Well, we know 4 is not 0, so that means either this one has to be 0 or this one has to be 0. So the way we figure it out is we just set up two tiny little equations. We say x minus 2 has to equal 0 or x plus 3 has to equal 0. And then we just solve these. So we subtract 3 from both sides and get x equals negative 3. We add 2 to both sides and we get x equals 2. So right there, those are our two answers, which is choice 3. Because either one of those numbers will give us a 0 inside of the parentheses, and then once you multiply by 1 0, it sort of wipes everything else out. Alright, 2. Which of the following represents all the values of x that solve x squared plus 6x minus 16 equals 0? Alright, so this one's not set up for us, so we have to do the work. We actually have to factor this. Because there are three terms, we're going to be looking at the multiply and add technique. So we're going to need two numbers that multiply to negative 16 and add to positive 6. Remember, you can use your calculator to help you out on these. We would just go to y equals, type in negative 16 divided by x, bring up our table, and then we just go through. 1 minus 16, nope. 2 minus 8, nope. 4 minus 4, nope. 8 minus 2, yeah, that'll give us a positive 6. So this becomes x plus 8 times x minus 2 equals 0. Alright, so we factored it, and now we have to do this extra little step. So we're going to say, alright, either x minus 2 has to be 0, or x plus 8 has to be 0. So add 2 to both sides, x equals 2. Subtract 8 from both sides, x equals negative 8. Alright, so let's see if we've got that choice over here. And here it is, choice 1, negative 8 and 2. Alright, number 3. Solve each of the following quadratic equations and check. So we're going to show you how you can check these as well. Alright, so y squared minus 3y plus 2 equals 0. So again, there's three terms, so I'm looking for two numbers that multiply to 2 and add to negative 3. Alright, and I don't even really need the calculator for this one because the only numbers I can come up with that are going to multiply to 2 are 2 and 1. Now, because we have to add 2 and negative 3, it's going to be negative 2 and negative 1. So this is going to be y minus 2, y minus 1 equals 0. Alright, so the factoring part's just the same as we've always been doing, and now we just have this extra little step. Y minus 1 equals 0, plus 1 plus 1, y equals 1, y minus 2 equals 0, plus 2, y equals 2. Okay? So one way you can check these is you can go to your y equals. In y1, you can put the problem. Now, even though they're using y's, we're going to use x's. So x squared minus 3x plus 2. So the left side of the equation goes into y1. The right side of the equation, which is just a 0, goes into y2. Alright, so that's the left side of my equation. That's the right side of my equation. I can bring up the table, and then I just check my answers. So one of my answers was 2, and we can see that y1 and y2 match, so that tells us that it's right. The other answer was 1, and I can see here that y1 and y2 also match, so that gives me the confidence that I did that one correctly. You see, the only place where they match is at the two answers that I came up with. Everywhere else, you get something different. Okay, let's try the next one. Okay, 10p squared plus 90p minus 100 equals 0. All right, anytime you have a number out in front of the variable squared, it's a good bet that we're doing factor completely. So factor completely means to factor twice. All right, and our first move is going to be to do a GCF, and then in this one, because we have three terms, we're going to follow that up with the multiply and add technique. Okay, so first thing we need to do is figure out the GCF of 10, 90, and 100. So again, if you have trouble with these, you can always just go to Math, Num, and then choice 9, and then type in two of the numbers, 10, 90. You'll get an answer. When there's three terms, you really need to do it again, and then you use your answer and whatever number's still left. Now in this case, we got the same thing both times, but that won't always happen. All right, so we're going to take out a GCF of 10. All right, so we've got 10p squared plus 9p minus 10 equals 0. I'm just dividing each of these by 10. And now I'm ready to do my multiply and add, so I'm looking for two numbers that multiply to negative 10 and add to positive 9. So again, calculator can come in handy here. Equals negative 10 divided by x. Bring up the table. All right, 1 minus 10, that's not going to give me a positive 9, so that's not going to work. 2 minus 5, nope. 5 minus 2, nope. 10 minus 1, yep. That will give me a positive 9, so I'm going to do 10 minus 1. Okay, so let's set up our double parentheses here. We've got 10 on the outside, and then p plus 10 and p minus 1 equals 0. Now remember, one of these three things has to turn into a 0. We can't turn a 10 into a 0, so the only things we need to worry about are the p minus 1, that could equal 0, or the p plus 10, that could equal 0. So we subtract 10 from both sides, we get p equals negative 10. We add 1 to both sides, we get p equals 1. Okay? And again, if you wanted to check that, you go to your y equals, type in the left side of the equation, so 10x squared plus 90x minus 100. The right side is just a 0. We bring up the table, and then we have to check positive 1. Yep, they match there. And we have to check negative 10. And yep, they match there. So that shows us that we did it correctly. Okay, let's take a look at the back. Alright, number 5, x squared minus 9 equals 0. Alright, so what we see here is there are only two terms. And when there are two terms, you're probably looking at one of two options. You're either looking at dots, which is where we take the square root of both terms, or you're looking at GCF. Now, the way you tell is if you have perfect squares, you're going to be using dots. If you don't have perfect squares, you're going to be using GCF. In this case, x squared is a perfect square because we can just do x times x, and 9 is also a perfect square because we can just do 3 times 3. Now, if you're not sure whether something's a perfect square, at least when it's a number, you can just go to second x squared. That'll bring up the radical sign. Type in the number. And if you get an integer, you know it's a perfect square. If you get a irrational big long decimal, then you know it's not a perfect square. Alright, so the way that this works is I set up my double parentheses. The square root of x squared is x, so that's just going to go in the front. The square root of 9 is 3, so that's going to go in the back. And because it's this negative 9 here, you know that one of them has to be positive and one of them has to be negative. Okay. The other way you can think about this is these are two numbers that multiply to 9 and add to 0, which is why there's only 2 terms instead of the usual 3 terms. Okay? So equals 0, and now let's actually finish this off. So x minus 3 equals 0. Add 3 to both sides. X equals 3. X plus 3 equals 0. Subtract 3 from both sides. X equals negative 3. Okay. Alright, last question here. Again, we have 2 terms. However, this time they are not perfect squares. If I put in radical 7 into my calculator, I get a long decimal. So that is not a perfect square. So instead, I have to do GCF. So I can go to Math, Num, GCD, 7, 35. And the GCF here is going to be 7. Now, if we look, we can see that both of these have a y with them. This is a y squared, this is a y to the first. That means not only can we take a number GCF, we can also do a letter. And when we're doing letters, we always take the one that has the smaller exponent. So that would be the 7y to the first. So both of these are going to get divided by 7y to the first. We're going to bring that 7y out front. Again, you don't have to write the first. I'm just doing it up here because it can be helpful when you're dividing the variables. So 7 divided by 7 is 1. Y squared divided by y to the first. We subtract the exponents. So that just becomes 1 y to the first. Or we could just write that as y. You don't have to write the 1 y to the first, but you could. You could write 1 y to the first if you wanted to, and that would be fine. Negative 35 divided by 7 is going to be a minus 5. And then the 1 minus 1 is 0, so the y's can just kind of cancel out there. All right, equals 0. And now, either this 7y has to equal 0, because that'll wipe out everything in the parentheses, or this y minus 5 has to equal 0, because that'll wipe out the 7y. All right, so we've got two little equations here, plus 5, y equals 5. This one, divide both sides by 7, and y equals 0. All right, so those would be our 2 answers for this problem. Okay, that wraps up this homework. I hope this was helpful, and have a good day.